Hello and welcome back to SIG Mechanics. I'm Edmund. This video is going to be a complete breakdown of how the P320 manual safety works. We'll discuss the parts involved, how those parts interact with the rest of the P320, as well as take a deeper look at what's actually preventing a discharge when the manual safety is in use. To make things easier to understand, I'll also use 3D modeling to illustrate some of the internal mechanics, and I'm also going to explore and explain a unique built-in feature of the P320 manual safety that isn't widely known or discussed, and it's not shown in any of Sig Sauer's marketing material. However, it's critical to how the P320 behaves if the manual safety is ever abused or otherwise forced into a failure state. Let's begin. Okay, so for those of you who subscribe to SIG Mechanics, you know that not too long ago I announced the M-Safety project for the P320. And for those of you who don't know what this is, it's a toolkit that lets you take any non-manual safety FCU and with the assistance of a few templated cuts, will convert the FCU and the grip module into a manual safety model made to replicate the M17 or M18 models. And in doing so, it allows operators to modify the P320 further in order to meet their different operational preferences. Now, ever since I released that video, I had quite a few people ask me to make a video that shows you exactly how the P320 manual safety assembly works. And I think that has a lot to do with how the P320 manual safety doesn't operate to physically block the SEAR and instead prevents a trigger pull in a sort of indirect way. And so here is the P320 fully built, and this one's using the X series grip, so yours might have the standard grip module. However, it's all the same thing. And as you know, to activate the safety, you lift the levers, and to deactivate, you drop them down, and that's the basic function. So let's open up the P320 and take a look at the FCU and see this function in normal operation. Okay, so here is the FCU, and for those of you who are maybe newer to the P320 platform, the trigger is connected to the trigger bar. The trigger bar extends back and into the SEAR housing, and here you can see the trigger bar has a leg that extends back behind the SEAR. And now if I pull the trigger bar will move forward until it engages the rear side of the SEAR, and as you continue to pull the trigger, the SEAR will continue to drop until the striker is released and the P320 can discharge. Now, when you add a manual safety assembly, you're simply introducing 4 new components to the FCU. And so here is a completely stripped FCU that only contains the components required to make the manual safety function. And so you might notice that even though the manual safety assembly is 4 components, this FCU has 5. And that's because the SEAR pivot pin on the P320 actually plays 2 roles depending on if the manual safety is installed or not. And I'll talk more about the SEAR pivot pin in a minute. But for now, when the FCU is stripped of all other parts, what's left is the left and right levers. As you can see, the right lever has a housing built into it, and in the housing is the detent, which is this small steel part right here. And behind this detent is a small spring that keeps the detent under constant spring tension. Now, if we flip the FCU and take a look at the detent from the inside, you can see sort of the spring there hiding behind the detent. But more importantly, you can also see that the detent has this chevron-shaped extrusion formed into it. And that pointed edge there is what rides along the surface of the manual safety cutout, which is this scalloped shape here, where the 2 rounded edges meet at this apex point. And so when you activate or deactivate the manual safety levers, you're effectively just forcing the detent spring to compress as the chevron extrusion glides up towards the apex. And as you cross the threshold of the apex curve, the spring will rapidly decompress and drop the detent into the opposite side of the cutout. Now, at that instant, the detent's spring will force the right lever housing to rotate quickly and impact the SEAR pivot pin. And I mentioned the SEAR pivot pin earlier, and this pin does play a pretty critical role in the function of the manual safety, which I will talk about more later. But in the context of what happens when you activate and deactivate the safety levers, the right housing here has these 2 surfaces, which in conjunction to the SEAR pivot pin are there to create a hard stop as to how far the manual safety levers can rotate. And consequently, this is where you get that tactile feel or that click when you use the manual safety. Now, when you take a look at the FCU as a whole, at first glance, it seems that by removing all the other components off the FCU frame, there's really nothing about the manual safety assembly that actually blocks the SEAR directly, since as we established, the components of the assembly are all pretty much located on the right side lever. And if you didn't know what you're looking for, you'd really only see the left lever's cylinder passing through the FCU. And so I think that this is what throws people off, because how is it that a simple cutout on the FCU frame and a solid plain cylinder that passes through the general area where the SEAR is supposed to be actually prevent the SEAR from being pulled down? Now, if we look at the P365, which is widely regarded as having an extremely similar design and mechanical function as the P320, if we then take a closer look at the manual safety here, the 365 manual safety has this small hook formed into the cylinder, which when installed on the 365 and then activated, will rotate to a position where it will physically stop the SEAR from dropping. Now, unlike the 365, the P320 manual safety assembly uses some clever engineering that essentially does two things. First, it sort of relocates the hook we saw midpoint on the 365 manual safety. And second, it changes the safety style from a post-SEAR engagement to a pre-SEAR engagement. And what I mean by this is the P320 manual safety is not designed to stop the SEAR from dropping after it's been engaged like the 365, but instead it's made to stop the SEAR from actuation before engagement is ever even started. And it does that by using this small post here formed into the right lever housing, and in conjunction to this by using the trigger bar itself, which, as you can see over here, the manual safety trigger bar has a carved out recessed area at the back, which is engineered to catch the post during trigger travel. And so the mechanics looks like this. When the manual safety is disengaged, the post rests higher than the trigger bar, and so if the operator pulls the trigger, it will pass by it with no interruption. However, when the manual safety is activated, the small post gets dropped down into the recessed pocket of the trigger bar. Then if the operator pulls the trigger, there will be a small amount of trigger travel as the trigger bar connects with the small post, at which point the trigger bar can no longer move forward. Now, you might be asking yourself, just how much force or pressure can someone potentially put on the trigger so that they could theoretically maybe chip or break the small post, causing the manual safety system to fail completely and let someone discharge with the manual safety turned on. And so to show you what happens in that scenario, I'm going to put the P320 into a testing rig that will allow us to incrementally apply more and more pressure on the trigger while recording the resulting raw data. Okay, so this is my testing setup. I have here a force gauge tester that's directly mounted to a manual testing stand, which will allow me to basically turn the crank at the top, which, by the way, I am replacing the hand crank for a drill just to make the process faster. And as I incrementally turn the lead screw, we will apply downward force on the trigger. And the force gauge will basically then document how many pounds of pressure we are exerting onto the trigger, and it will display the peak force applied so that we can see where we capped out at once the assembly fails. Now, this gauge is rated for about 500 newtons or about 110 pounds, so one of two things will happen. Either the trigger will malfunction or we will cap out the 110 pound capability that this particular gauge is rated for. Now, to really capture what's going on inside the P320, I'm going to load it with a primed cartridge so that we can document if the striker is ever released. And I'm also going to be placing the P320 into a special holder that I 3D printed out of carbon fiber, which is basically there to hold the P320 upright. I'm also going to add a few heavy-duty zip ties to the testing rig because at a certain point, the trigger will be forced so far back that any additional force on the trigger will want to dissipate by either pushing or pulling the P320 forwards or backwards in some direction. So that this is here to basically keep the test going as long as we can so that we can capture as much data as we can. Okay, let's begin. All right, so everything is set up and ready to test, and you may have noticed that I swapped back to the original curved trigger here, and that's because I am using the M18 FCU, and so this is the curved trigger that is stock with that model. And I'm also purposefully swapping it because I want to explain something to subscribers about trigger geometries and how they affect a trigger pull. And so what you are about to see here does apply to all trigger models. It's just easier for me to present the following information using this particular trigger model, but I will give you more details afterwards. Okay, let's start the test. All right, so I'm just going to pause here. Right there, you did see the trigger move, and for all intents and purposes, that was a complete trigger pull. Now, I will note that the primer has not gone off, and we will verify that once I pull the primed cartridge out. But for now, we will just take note of the maximum force we reached at this time, and I will continue to keep applying force onto the trigger and see if we can maybe cap out the force gauge's rated maximum of 110 pounds. Okay, so we should be nearing the 110 pounds max rating. So let's just keep going. There it is. Now I don't see a silence button on the gauge, so I will lower the volume post-production, and hopefully that will be a little less annoying, because now that we're here, we might as well just keep going to see what happens if we put more pressure on the trigger until we maybe break the tester or the P320. So let's keep going. Now that was interesting, and it looks like we might have broken the P320 and the tester as well. I can tell you right now that the primer did not go off, but let's open up the P320 and take a look inside and see what failed. So the tester is actually okay, but the P320 did suffer some irreparable damage. As you can see, the trigger is no longer springing back to its start position, but also the trigger has lost all support. So it's just sitting loose inside the FCU, meaning that the trigger bar must be completely and irreparably broken. So let's open this up here. And here is the primed cartridge, which as you can see here, the primer has not marked it, meaning that through both incidents, first when we made the trigger fully pulled back, and second when we abused the over travel to the point of failure here of the trigger bar, the striker would not have made the P320 discharge. Now let's pull out the FCU here. And there you have it. The trigger bar is literally split into two pieces. Now, this actually breaks the flow of this video a bit because I did not expect this to happen, but I felt it was important to leave this in, so to let you see the types of things that happen when you abuse the trigger, so you won't have to sacrifice your own parts. But the trigger bar splitting is actually not the focus of this video, because I actually want to talk to you about what happened during the first incident where the trigger fully pulled back at about the 20-pound mark, but the primer still didn't go off. So in order to discuss that properly, I am going to get a new trigger bar installed here, and I'll spare you the details of having to watch all of that, but I'll skip forward to where I can rerun the test in order to replicate the trigger movement that we saw earlier, and then I'm going to explain what's going on inside the P320 and why it won't go off when the trigger was abused like that. Okay, so here we go. And there we have the trigger fully pulled again due to the trigger being abused. And so I'll slowly release the testing gauge so we can see what happens when we release the pressure. And you can see the trigger clicking back to the start position. So let's pull it out of the testing rig and talk a bit about what happened here. Now, before I pull the primed cartridge, let's carefully test the manual safety levers, and they do seem to be moving freely, and it doesn't feel like anything's out of spec. So let's just remove the primed cartridge now, and I'll put that to the side for a second, and we will do a quick function check here. So with the safety on, no trigger pull, and the P320 is rendered safe, and with the safety off, the striker releases, and we can reset the trigger. And as you can see, it's back to normal function. Now, let's take a look at this prime cartridge. And here you can see that there are no striker markings on the primer. So although we did document a complete trigger pull, the P320 is not actually discharging. And this is due to an additional built-in safety feature of the P320 manual safety that oddly I haven't heard anyone talk about before, and it's not mentioned on SIG's marketing material, but it is pretty critical. So let's take a look at what happened here. So on the P320, the small post here was engineered in a way that will not just stop the trigger bar from moving forward, but also account for how to deal with operator abuse. And I think that this is a pretty great feature because beyond the obvious, Simple mechanics like this that have a significant impact on function is why I really like this platform. If you think about it, there's no way that this small pin here would ever be able to do all the heavy lifting in a situation where someone is either accidentally or negligently abusing the trigger. So when someone is exerting great force on the trigger, at a certain point, the connection between the post and the trigger bar's recessed slot will slip. And so what happens at this point is it behaves like a trigger bar disconnector. And so the sloped curve of the trigger bar will slip onto the rigid position of the post, and the manual safety lever will then force the trigger bar down. And when this happens, the trigger bar is then dropped underneath the SEAR's leg. And from that point on, no matter how much energy or force you put on the trigger, there's no way the trigger bar will be able to walk itself back behind the SEAR until the operator releases the trigger, and the manual safety will reset back to its normal state. And therefore, so long as the manual safety is activated, you will not be able to accidentally pull the trigger, and even if you did, the P320 will remain in a safe state. All right, so before I move on, I'm going to quickly explain why I thought it was important to use the curved trigger during that test, beyond, of course, the reasoning that the curved trigger is the stock M17 and M18 trigger model. And so the main reason is that I wanted to easily be able to show you the additional safety feature we saw, where pressing the trigger hard enough caused the trigger bar to go into disconnect mode. And I said easily because even though that feature does occur with every trigger model, how much force you need to cause it is dependent on the geometry of the individual trigger. So with some triggers, it will require a force that's much higher than others in order to replicate that action. And the skeletonized trigger here is a good example of this, where with this trigger, it will take substantially more force to cause the trigger bar to disconnect from the path of the SEAR. But like I said, with enough force, it will happen. And for those curious as to why it's harder with some triggers and easier on others, it's basically down to how the trigger changes the direction of travel that the trigger bar takes during a trigger pull, which I can get into on another video, but for the sake of trying to keep this one at a reasonable length, the connecting pin here on each trigger will define the start and end angle that the trigger bar will take as you pull the trigger. So just to be clear here, the fact that a trigger will take more or less force to activate that disconnect feature doesn't define if the P320 is inherently safer because of that trigger. As a matter of fact, having a trigger that disengages sooner probably gives the P320 internal parts more life, since you're not stressing the trigger bar as much as one that does not relieve the violent pressure or force, which theoretically might avoid situations like this one here. All right, so with that clarified, let's move on. Okay, so now we've gone over the basic mechanics of the P320 manual safety assembly, and we've seen and tested the limitations and somewhat additional functions of that safety. So now I want to go deeper and provide subscribers with details about the engineering of the manual safety, because it's very interesting how SEAR was able to take a complex mechanical system and simplify that into what you see today, because with this design, without having to re-engineer their other components, you're now able to introduce 4 parts, and you've changed the function of an entire platform. And not just that, but also in understanding how the system works, you will have made it much easier on yourself to do things like maintain and service your P320, as well as swap out parts if needed. And so let's start with how the manual safety assembly is even able to work in the first place, because for all the parts of the manual safety to come together and do what they're supposed to do, the parts had to be engineered in a way that will let you easily purchase and then install those parts yourself if the P320 didn't originally come with those parts. So I want to start with a very critical component that at first glance looks pretty basic, but in reality is sort of the whole reason the manual safety as you see it today is even physically possible. So let's talk about the manual safety detent. So as you know, the detent is this tiny part that, as you saw earlier, has this chevron extrusion formed onto it, which when it meets the FCU frame, rides within the cutout and allows you to engage and disengage the safety. However, this part is also the reason why you only simply need to slip the left lever through the FCU and then connect the right lever to it. And it's really the part that keeps the entire manual safety mechanically held together. And so here you can see the detent is designed with one leg longer than the other, and this does help for orientation because the leg only drops in one way. But more importantly, when the detent is installed correctly, when it comes time to interlock the left and right levers, the detent is designed so that the longer leg, when it's compressed, will make its way into a cavity on the right lever housing. And this creates a wedge that now retains the left lever from coming apart from the right lever. And the length of this leg is also pretty critical because it works in conjunction with the SEAR pivot pin so that the mechanical locking occurs the moment that you ever so slightly rotate the levers in order to give the SEAR pivot pin the gap it needs to be pushed all the way through the FCU. And this relationship between the detent and the SEAR pivot pin actually goes even further because the entire reason the manual safety doesn't just fall apart while you're using it is due to the fact that the SEAR pivot pin forces you to slightly rotate those levers, which by doing so puts the detent under constant spring tension. But now the levers cannot spring back to an uncompressed state because the SEAR pivot pin is now slotted between these two surfaces of the housing that we talked about earlier. And this effectively has created a stop point on the manual safety lever that prevents the levers from returning back to the point in which the detent's longer leg can slip out of the right lever's housing, thus mechanically releasing the two parts from one another. Now, beyond just how it works to activate and deactivate safety and in relation to the detent we just spoke about, I need to quickly talk about the shape of the FCU's manual safety cutout and what role it plays and how it affects the installation and disassembly of the P320 manual safety. And so you'll notice that the FCU cutout is not a perfectly symmetrical design, but instead the bottom half of the shape is actually slightly more elongated, and this bottom oblong shape is made that way to allow the installer some clearance so that as you drop the detent in place, it's not instantly compressing the detent spring, thus locking the left and right levers together instantly. And the cutout is simply giving you a starting point so that you can get the detent's chevron fully seated into the FCU frame in preparation for that final slight rotation that mechanically secures the assembly in place, and vice versa for disassembly. And when it comes time to disassemble the manual safety, you can use the cutout to carefully decompress the detent spring by guiding the detent along the cutout surface, which is of course a feature that you don't generally appreciate until you have the small detent, or even worse, the even smaller detent spring fly across your workbench. In any case, with that final bit of detail, you now have a full and complete understanding of the P320 manual safety and how it works. All right, so I hope you learned something new today. If you're here because of the M Safety Conversion Toolkit, I want to thank you sincerely for your support of the SIG Mechanics channel. And for anyone considering picking up one of these kits, I want to note that version 2 of the toolkit is now available at the SIGMech web store, as well as several other dealers. And so version 2 of the kit now gives you the ability to convert a standard style grip module, as well as the X10 and X series grips. So check that out. Of course, if you have any questions, please feel free to leave a comment on this video because I do try to answer each and every one of your messages. Also, a special thank you to those of you who support this channel, either by subscription or sharing these videos on various platforms and forums. You really have helped SIG Mechanics grow because of it, and it's always great to know that you guys continue to enjoy my work. All right, that's all I have for you today. See you soon.